Okay, we'll pick up where we left off in the last video. We have the area function as 2x squared plus 85 minus 3x over 2 quantity squared. And we want to find out where that's 0. Sorry, we want to find out where its derivative is equal to 0. So I'm going to start working on the derivative at this point. Okay, first I'm just going to clear up a little bit of space there. And I'm going to start working on the derivative of a, the area function. Now the first term is easy, that's just 4x. Now for the second term, you might be tempted to multiply this all out. It's going to take you a lot of time. Those are messy numbers. You got fractions, you got big numbers. It's much easier to use the chain rule at this point, and this is how the chain rule is going to work. We bring down the 2, multiply that times, leave the inside alone, which is 85 minus 3x over 2, reduce the exponent to 1, and simply multiply that by the derivative of the inside function, which you should see is just negative 3 over 2. And so that makes the derivative a lot simpler. Yes, there's still some stuff to take care of in there, but it's done. It's all done at that point. Now we do need to find out where this is going to be 0. Simplifying, I can cancel out those 2's there, and that's going to again make it a lot simpler. And so now I'm at 4x minus, I still have the minus sign from the negative 3 over 2, minus 3 times the quantity 85 minus 3x over 2. Okay, at this point I can multiply it out, and it's a much simpler calculation. 4x minus 255 plus 9x over 2, and that 4x is really 8x over 2. So I have a total of 17x over 2 minus 255. And that will be 0 when 17x over 2 is equal to 255. And that happens when 17x is 510 or when x is equal to 30. Now this is the first place that's really tricky. You might be attempted to think that, or to conclude that x equals 30 is going to be the maximum value, is where it's the maximum, it's the value of x that yields the maximum area for the two fields. And you really should do a test on this. Again, if we know that x varies between 20 and 50, with 30 in the middle there, or in between anyway, we can now test some values. And if you were to go back to the derivative function and plug in x is equal to 25, and there you have 17x over 2 minus 255 is the derivative. If you were to plug in 17 times 25, and you can do this whatever, you're going to wind up with when you plug in 25, you get 17 times 25, which is 425 over 2, which is less than 255, so you're going to end up with a negative value there. And when you plug in x is equal to 35, you're going to end up with, I believe it's 595 over 2, which is more than 255, and so that's going to be positive. Well, from that sign chart there, what we actually have at x equals 30 is not a maximum, but a minimum. And if you are like me, you shake your head and say, why, how could that possibly be? We're trying to find a maximum, so you have to be really careful here. And this is where you need to bring in the idea that if it is a closed interval, it has to have an absolute maximum, and that maximum will either occur at critical numbers or endpoints. Well, the only critical number is a minimum, and so that can't be the absolute maximum. And what we're going to have to do then is test the function at the endpoints, and we could test it at 30 also, just to verify for our own sake. But when we plug in a equals 20, I won't go through all the calculations. Now you're going back to the original function, which is the function I circled in orange there. And you do the calculations. You plug in 20 for x, and you end up with 3825 square yards. Plugging in 30 for x, you're going to end up with 3400 square yards. And that's, as it should, that's a minimum. It should be, we're expecting it to be a low point. When we plug in 50 for x, we get 5100, which is the maximum. The moral of the story is, on a closed interval, you must test the endpoints as well as the critical numbers.